Okay, so the second part of this section is called limits at infinity instead of to infinity. So that means that x is approaching a positive or negative infinity. So what it looks like is we will have a limit in this, and then this time, instead of having our limit answer be positive and negative infinity, now positive or negative infinity is what we are plugging in to the equation. So that's the difference between limits to infinity, we get an answer that's infinity. Limits at infinity mean we're plugging in infinity. So keep in mind that what this means if we're looking at a graph, if we have our x and y axis, this way is x approaching negative infinity. So we're going to be kind of looking in a different direction this time. And this way is x approaching positive infinity, because this is like 1, 2, 3, 4, 5, and then it keeps going to really, really, really huge positive numbers. And same thing this way, -1, -2, -3, -4, -5, and then really, really, really huge negative numbers, which is why that's x approaching negative infinity, and this one is x approaching positive infinity. So let's look at a very similar example that we looked at in the last video, but we're answering a different question this time. We have the limit as x approaches infinity of 1 over x. Okay, this is different. The last time we were looking at 0 and we were going to get an answer of infinity. Well, let's see. If we 1 over x, pretty much the only way to do it is a graph or a table. If you watched the last video, the graph of 1 over x looked like this. It has it in the first corner and the third corner quadrants. And this is where our graph is. So if we are looking as x approaches positive infinity, that's this way. You're looking this way along the graph because this is x approaching positive infinity. And these are asymptotes. So this value is going to get really, really, really close. It's going to keep going down and it's going to follow that trend. And if we were looking at where that would get close to, on the y-axis, that would be 0. Because it's going to get really, really close to the x-axis, which is y equals 0. Answers to limits are always y values. So just because we're going this way on this graph, we're looking where this graph is going to end up. It's going to get really, really, really close to 0. So our answer here is 0. Or if you aren't good with that graph representation, the other thing that you can look at is this time you don't have to do a graph. You could plug in infinity and get 1 over infinity. So remember in the last video we talked about this. We have a number over infinity. That makes very, very, very small pieces, and our smallest number is 0. So that goes to 0. Okay, so let's look at a couple more examples. We have the limit as x approaches infinity of 4x plus 1. Okay, so you could either graph this and try and think about it, or you could plug it in. We would have 4 times infinity plus 1. Well, 4 times infinity, our rule with infinity is that multiplying by 4 is still going to make it go to infinity. That doesn't change anything. Adding 1 is really not going to change the idea either. So our answer there is infinity. And that's it. Let's look at another example. We have the limit as x approaches negative infinity. So this time we're plugging in negative infinity of x cubed. Okay, well, it's going to be x cubed, and we're plugging in negative infinity. So if we multiply a negative 3 times, we still get a negative. Infinity is still going to be infinity. That's not going anywhere. So our answer there is negative infinity. Another example, we have negative 4x squared plus 2x minus 1. You want to be careful here because if we do just plug in infinity, we would get squaring infinity doesn't change anything, multiplying by 4 doesn't change anything, we get negative infinity, plus 2 times infinity, we get infinity minus 1. Well, right here is an indeterminate form. So that means we need to try something else. The first thing that I would try is I would graph it. I would look at the equation and see if I know what that general graph looks like. Well, this is a quadratic. Negative 4x squared plus 2x minus 1. So it's either going to be an upward facing parabola or a downward facing parabola. I look in front of the x squared, I have a negative number, so this is going to be upside down. So as I go along, I'm looking at positive infinity, so I am going this way. Well, this graph has no intention of stopping. It's going to keep going down, okay? But it's also, yeah, it's going to keep going down. Sorry, I confused myself for a second. It's going to keep going down. So when we look at our answer on the y-axis, then going down means negative infinity, and that's our answer. So this time we use the graph because plugging in infinity gave us an indeterminate form. So you want to be careful. There are a couple more things that we can do. If we look at this next example, where is it? I guess I didn't type it up. So one more example. We have the limit as x approaches infinity of 2x minus 1 divided by x plus 1. When we plug in infinity, we end up getting infinity over infinity. This is one of those indeterminate forms. That means what we did here is not going to work. It's not going to give us an answer. It's like dividing by 0. Did not work. That's what indeterminate form means. So here's what you can do. I wouldn't be able to graph this without a graphing calculator, but this is a problem that might be on the non-graphing calculator portion of the AP exam. So what you want to do is you want to divide the numerator and the denominator by the highest x term that you see. So in this case, if I'm looking at all the x terms, I have 2x, I have x. Well, the highest one that I see is x. I don't see x squared, I don't see x cubed. X is the highest that I see. So I'm going to take this limit, and I'm still going to write a limit as x approaches infinity. On the top, I still have 2x minus 1. I'm going to leave a gap. And on the bottom, I still have x plus 1. So I'm going to divide the numerator by the highest term that I see as x, and divide the denominator by the highest term, the same exact thing. Because remember, we can do the same exact thing to the numerator and the denominator, and we are not essentially changing the problem. We're just making it into a format, changing it into a format that we can work with. I know this looks crazy. I know you hate fractions, and now we've just made like a 4-layer fraction cake. It's fine. It's not a big deal. Okay, everything is going to work out, so just relax. So what this means is that basically we have the limit as x approaches infinity, and each of these terms is individually divided by x. So we have 2x divided by x minus 1 divided by x over x divided by x plus 1 divided by x. So we can simplify this again and leave it as the limit as x approaches infinity. But we can cancel things out. Like these two x's can cancel, that can cancel, x divided by x is 1. So we have 2 minus 1 over x. 1 plus 1 over x. Now we use our infinity rules. So think about this. The limit, we are going to take the limit of each of these things individually. We have the limit as x approaches infinity of 2 minus the limit as x approaches infinity of 1 over x over the limit as x approaches infinity of 1 plus the limit as x approaches infinity of 1 over x. This green step that I just wrote out, you do not have to write every time, okay? I'm just showing you exactly what we're doing step by step. So if you were doing this later on, you would definitely need this first step. You would definitely need maybe the third step, and then you could go straight to the answer from there if you wanted to. But I'm just showing you guys step from step. So the limit as x approaches infinity of 2. Well, there's nowhere to plug in infinity. I have 2. Minus, plug in infinity, I have 1 over infinity. Over 1 will stay 1, plus 1 over infinity. Well, 1 over infinity means really, really, really small pieces. So those go to 0. So I have 2 minus 0 over 1 plus 0, which is 2 over 1. 2 divided by 1 is 2. Oh, I don't know why that came out. Okay. There we go. So 2 is our answer. So you could really write the first, the third, you could skip to here if you wanted to and get your final answer as 2, okay? So I wrote this out very long so that you could see every single step and see what we're doing. But you don't have to write every single step all the time, okay? So use this idea, dividing the numerator and denominator by the highest x term. What I want you to do is I want you to try these 3 on your own. Pause the video. Use these 3 examples to practice dividing the numerator and denominator by the highest term, okay? And then after you've tried to do those and solve them out on your paper, then come back to the video, see if you've done it right, and we're going to do something with this information. So pause for a minute, pause, and then press play, and we'll make sure that everybody understands what's going on, okay? Okay, coming back from your break. So you should have solved these 3 problems. Well, not your break, my break, I guess. Each of these, you would divide the numerator and denominator, and you would do that because if you plugged in infinity, if you plugged it in the top here, you'd get infinity. In the bottom, you'd get infinity. Each of these, you are going to get an indeterminate form. So we have to do something else. So that something else, what I suggested, was that you rewrite these limits. So this becomes the limit as x approaches infinity of 2x plus 5 divided by the highest term that I see is x squared. So x squared, big fraction, 3x squared plus 1 divided by x squared. And then I divide all those through. So I have the limit as x approaches infinity. 2x divided by x squared, that's going to be 2 over x, plus 5, doesn't have anything to cancel, stays x squared, over 3, because the x squareds cancel, 1 doesn't have anything to cancel with. So when I plug in infinity, infinity into here is going to give me 0. Infinity into here is going to give me another 0. Infinity into 3, there's nothing to plug, so it stays at 3. Infinity into the last one is also going to give me 0. So I have 0 over 3, which is fine. It just gives me a 0. Oh, sorry about that. It just gives me 0. That's my answer for that one. Done. Okay. The next example, we would have the limit as x approaches infinity. And the highest still that I see is x squared. It's on the top and the bottom this time. So I have 2x squared plus 5 over 3. Wait, nope, I want to divide. I want to get rid of that. Divide it by x squared. And then 3x squared plus 1 divided by x squared. And when I do that, x squareds cancel, so I have 2 left here. This is a limit. Make sure that you're writing limit every time. I almost forgot. Plus 5 doesn't have anything to cancel. 5 over x squared. over 3, the x squareds cancel, 3 plus 1 doesn't have anything, x squared. When I plug all that in, 2 stays 2. Infinity in that denominator makes 0. 3 stays 3. Infinity in this denominator makes 0. Well, this time I have 2 over 3. And then the last one, I have x cubed is the highest term. So I have the limit as x approaches infinity. 2x cubed plus 5, divide all that by x cubed, divided by, scroll down a little bit, 3x squared plus 1, divide by x cubed, and do this. So they cancel and leave a 2, nothing to cancel with 5. Oops, this is a limit still. It's really easy to miss. Make sure that you're writing it on every step. We have 3 over x plus 1 over x cubed. And when I plug in infinity, 2 stays. Infinity here makes a 0. Infinity here makes a 0. Infinity here makes a 0. Whoops. 0 on the bottom. Ew. This limit does not exist. Goodness. Okay. So, sorry, my computer's being weird. With all of this information, take a second, look at the 3 equations. What has really changed between these 3 equations? Well, what has changed is on the top, this x right here. First it was x, then it was x squared, then it was x cubed. Everything else in these equations stayed the same, but it changed the answer. So look at this middle answer, 2 over 3. 2 over 3. These powers were the same. Well, guess what? That's a rule. That's a shortcut for limits. When you are finding limits at infinity, plugging in infinity, and you have the same powers on the top and the bottom, you can just take the first 2 numbers. You don't have to do any of this work in the middle. We had to do the work in the middle, okay? Because you need to know this process. If you forget the rule, you need to know how to solve the problem. But good news, you don't always have to do this work because there are rules to help you out. So here's my page to write the rules. Well, I'll make my own page. So, limits at infinity, the rules. Limits at infinity, rules. Here they are. So, if we're taking a limit and its x approaches infinity, and we have polynomial on the top, so we have like a, maybe this is 2x squared, we don't know. A x to the m. So there, a is the number in front of x, m is the exponent, and then whatever else is happening after. And we have b x to the n. So we have a different power. Maybe it's the same, maybe it's different. So then we can apply these 3 rules. All right. If m is less than n. So if this power on the top is less than the one on the bottom, then the limit is equal to 0. Every time. Every time. If the one on the top is smaller. So if we have x squared on the top, x cubed on the bottom, your limit is 0. You're done. No further work. Okay? If they are exactly the same, then your limit is equal to a over b. So whatever numbers are right in front of those, if it's x to the 7th and x to the 7th, and they have a 1 and a 9, then it's 1 over 9. That's your answer. Whatever numbers are right in front of those highest powers. Okay. And then if m is greater than n, so this time the bigger power is on top, x cubed is on top, x squared is on bottom, or whatever it is, then your limit doesn't exist every time. So you can go back and apply those to the rules or the problems before, or we can apply it to this example. So think about those rules. Hopefully you have them written down. We have the limit as x approaches infinity. On the top, we have 3x to the 7th plus 9x to the 4th minus 11x minus 7. Then on the bottom, we have 12x to the 5th plus 8x to the 6th plus 9x to the 7th. Be very, very careful, because the highest power up here is in the front, but the highest power on the bottom is all the way in the back. You care about the highest power on the top and the bottom. That is what you are comparing. Do not compare the 12x to the 5th and the 3x to the 7th. The rules don't apply to that. They apply to the highest power on the top and the highest power on the bottom. Since these have the same exponent, our same exponent rule is that we do the coefficient on the top, number in front, and the coefficient on the bottom, the number in front, which is 1 over 3. 3 over 9, 1 over 3, same thing. Okay, so you can apply those rules every time, but just be very careful, because the AP exam is fully aware of these rules. They know that it makes it relatively easy if you can recognize it. So on purpose, they do not always put these in standard form. And as a matter of fact, they're probably not going to be. But they're not always in standard form, meaning the biggest one in the front. So you need to be sure and look for the biggest one. Okay, so just be careful there. This is the end of section 1.4 and the end of the notes and of chapter 1. So this concludes your notebook. All the way 1.1 to 1.4 is your notebook check on Friday. So make sure that you have all of these notes. Very, very important.